after we plug in 3 and we find we get 5 over 0, and we know we're dealing with a vertical asymptote here at 3, we graph out the function. Actually have it up here from the last class, but that's how I plug it in. Make sure you're using parentheses in the appropriate positions here. Graphing that out, we see that vertical asymptote occurring right here where x is 3. And what we have to do to explain how this limit's going to be evaluated is we have to look at the left-hand limit. So we take the limit as x approaches 3, approaching 3 from the left. We apply it to this function. And we have to look at the right-hand limit. Take the limit as x approaches 3, approaching from the right, apply to the same function. We do this once again because we're going back to the foundation of the definition of a limit. The left hand, the right hand sides have to sync up here. So since we have the graph, exploring from the left side, approaching 3 here from the left, we see the graph's going down. So we would say that limit as x approaches 3 from the left applied to this function equals negative infinity. As far as the limit as x approaches 3 from the right applied to the same function, what that's going to equal, well, approaching from the right, graph's going up. So positive infinity. Now, it is possible if you start off this limit problem by taking 3 and plugging in and getting 5 over 0, which you know is undefined, it is possible that this limit could work out. It's just you're going to find it's going to work out to be something infinite. And that would be the case if both of these were the same kinds of infinity. If they were both positive infinity, then I could say, okay, this equals positive infinity. If they're both negative, then I say this equals negative infinity. But they're different. And because they're different, the limit does not exist. So to justify that a limit does not exist, we look at the left-hand limit and we look at the right-hand limit. So we've got this piecewise defined function, and for this piecewise defined function, I want us to find the limit as x approaches 2 as this limit is applied to the function. One would think that, based on what we've done so far, all you got to do is take this 2 and just plug in. For these pieces, you could just plug in where it's defined, and where it's defined is up here, right? This is where x could equal to. But the problem is, with this piecewise defined function, and with what we know about the definition of functions, the breaking point occurs at the value we're trying to approach. So that means we're really only considering one of the paths if I'm taking 2 and only plugging in up here. So what we do, similar to the last problem, we branch off. We set up a limit as x approaches 2 from the left side. And we appreciate that needs to be applied to this function somehow. Since I'm dealing with 2 pieces, I need to be specific about which piece I'm applying this to. Well, from the left side, we are talking about x values that are less than 2. Right? From the left side. So that would make sense then to pick the first piece and apply this limit to x squared plus 3, because that's where, for this function, we have defined x values that are less than 2. Less than left side. At the same time, we set up a right-hand limit. Here, you could say by process of elimination, it might make sense to apply it to the second piece, since we've already used the first. But it does make sense to use that second piece because if the values are going to be to the right of 2, they're going to be larger than 2. They're going to be greater than 2. So I set up 2 new little limit problems down here. I've got my specific pieces I'm applying that limit to for each part. If I go back to the basics of figuring out a limit, I'm taking this number here that x is approaching, I'm plugging in for x. I'm seeing what I get back. Well, I plug in for x here, 2 squared, 4, add 3, 7. If I take 2 down here, plug in for x, 2 times 2, 4, add 5, get 9. So the limit as x approaches 2 from the left, applied to this piecewise function is 7. The limit as x approaches 2 from the right, applied to this piecewise function is 9. Those are different values. Since those are different values, the limit as x approaches 2 applied to this function does not exist. But say, for instance, each of these had been 7. Had they both been 7, then the limit as x approaches 2 applied to this function equals 7. But this is how I demonstrate my mathematics to justify what the limit is. We've got absolute value, and we've taken this number and we've plugged in and we get 0 over 0. And this is only when we've taken that number, plugged in and got 0 over 0. We're going to branch off again and do this left-hand limit and right-hand limit approach. But as I stressed in the previous problems, we got to apply this limit to something. So if we take the limit as x approaches 3 from the left, what we're going to apply it to, well, I go back to my function here. I know with certainty for this function it's over x minus 3. My question is about the absolute value. Well, if I'm approaching from the left, talking about values that are less than 3, as far as my absolute value is concerned by definition, I'm taking that x minus 3 out. I'm applying a little negative to it because I'm looking at the opposite of that expression. Now from the right, it's the same kind of idea. Same function. I know it's got to be over x minus 3. But it's that absolute value on top that seems to be the hang-up. Since I'm approaching 3 from the right and those values are greater than 3, then all I have to do with this absolute value is take the expression out of x minus 3 and leave it alone. Because I know to the right of 3, it's going to be just x minus 3. Now, as far as factoring is concerned, we actually do have some factors here in play that we could do some reducing with. You've got this x minus 3 here, this x minus 3 here. As it turns out, they divide out. And all you're left with is that little negative, right? Meaning you're left with -1. So the limit as x approaches 3 from the left equals -1 when we apply it to this function. And from the right side, well, x minus 3 over x minus 3, that divides out altogether, leaving you with 1. So limit as x approaches 3 from the right side, apply to this function equals 1. Meaning, the limit as x approaches 3, apply to the function overall, does not work since these numbers are different.